So what we're going to do now is take all that you noticed about quadratic functions and kind of put it into some rules about quadratic functions in vertex form. The first thing though, what is a quadratic function? Do you know? The equation has a degree of 2, which means the equation has an x squared. And the shape of the graph is a parabola, so it has that vertex and opening, something like that. Could be upside down, but that basic shape. That's what a quadratic function is. So when you look at a graph, you know it's quadratic because it makes that shape. When you look at the function or the equation, you know it's quadratic because it has an x squared in it.
Can you spell parabola? Oh, no, it's right there.
Here's what the vertex form of a quadratic function looks like. Y equals a x minus p squared plus q. A, p, and q are numbers that affect the width of the graph and the placement of the graph and the direction of the graph. All parabolas can be thought of transformations of y equals x squared. So y equals x squared is like your parent function, your basic quadratic function, and then changing the a, p, and q values, adding something to the x or to the end or multiplying it by something, changes the way it looks, so it transforms the graph. By changing the parameters in the equation, we change the graph. So let's talk about that a value, the a parameter. Here are some graphs to look at. I know it's kind of small, but I'll read you the equations. The red one in each of them is just y equals x squared, that kind of parent function I was talking about, y equals x squared. And the blue one here, I've changed the a value. So this is y equals 2x squared. And you can see how that one's different than y equals x squared. It looks narrower. This one, the second one, I've changed the a value to -1/2. And that does two things. It makes it open down instead of up, and it looks wider. So this is the information that you need, what we're going to fill in here. If a is greater than 0, which means a positive number, the graph opens, what goes in that blank, do you know? Up, yeah. If a is greater than 0, the graph opens up. If a is less than 0, which means it's a negative number, the graph opens down. That's the easiest thing to tell from the a value. If it's positive, it's going to open up. If it's negative, it's going to open down. But also this, if a is greater than 1 or less than -1, so that would be like this one where a is 2, that's greater than 1. Or if it was -2, -3, -4, greater than 1 or less than -1, the graph is narrow compared to y equals x squared. But if it's between -1 and 1, so something like 1/2 or 1/3 or 2/3, something like that, then the graph is wide. And when I say wide or narrow, I mean compared to the graph of y equals x squared. The p parameter, so here we have y equals x squared again, is the red one, but this purple one is y equals x plus 5 squared. And what happens is the graph shifts over 5 to the left. This one we have y equals x squared is the red one, y equals x minus 3 squared, that's the yellow one, it shifts over to the right. This is the part that gets a little bit confusing for people. The equation is y equals a x minus p squared plus q. So for this one, which is x plus 5 squared, what's the p value? What is p equal to here? -5. Because it's the number that's subtracted from the x. That's where you find the p. This says x plus 5. So to add 5, what are we subtracting? Well, we're subtracting negative 5. This one over here is x minus 3 squared, which means the p-value is equal to 3. Because we're subtracting 3 from x. P is the value that you subtract from x. So really you need to take the opposite sign of what you see to find the p-value. If it says x minus 3, we're subtracting 3, so p is 3. But if it says x plus 5, we're subtracting negative 5, so p is negative 5. That can get a little bit confusing for people. But you have to remember that if you're talking about the vertex, you're going to need to switch that sign. So here it says if p is less than 0, which is the first one, p is negative 5, that's less than 0. The graph is translated to the left. P units. That's how far it's translated. Translated to the left, p units. So if it's negative 5, it's translated negative to negative 5. If p is greater than 0, the graph is translated to the right. P units, that's how far it goes. So the absolute value of p tells you how far it goes. But if it's a negative number, it goes to the left. If it's a positive number, it goes to the right. Here's the Q parameter. This one's a little bit easier because you don't have to switch the sign. Here the red one again is y equals x squared. The blue one is y equals x squared plus 4. So the p-value here is 0. There's nothing subtracted from the x. It's added to the whole thing, the whole x squared. And what happens to the graph? Moves up 4. This one, the equation is x squared minus 6. Y equals x squared minus 6. The whole thing moves down 6. So if q is greater than 0, the graph is, translated up. And if q is less than 0, the graph is translated down. So translated basically just means moved, right? The whole thing moves up, the whole thing moves down, depending on that q value. The last thing. The thing that we talked about before that I didn't actually say here is if you're moving p units to the right or left and q units up or down, then p and q is the vertex of a parabola when it's in that form. So the vertex is p and q. And then this question asks us to determine the vertex. What would you say is the vertex of this first one? Y equals negative 3x minus 1 squared minus 4. 1 and negative 4. Now that's not the only thing we can tell about that graph. But this one is going to go 1 unit to the right and down 4, which makes the vertex at 1 and negative 4. What direction is it opening?
Down.
Down. And is it relatively wide or relatively narrow?
Narrow.
Narrow, right. How about the second one? What's the vertex? Negative 2, negative 1. Open up or down?
Up.
Up. And relatively wide or relatively narrow?
Wide.
Relatively wide.